kind of focus in on the linkage. You see how the linkages come up and essentially flex. This is the flexure member here. Basically, differential. That's a lot more movement than you'd ever would get.
Yeah.
You would ever need on a cavity, but essentially, so that's the other good thing about this design. It's got a wide range.
Yeah.
Pretty wide dynamic range.
Yeah, you don't have to get it so close with the
got a lot of dynamic capability.
So what would be the range of motion, to?
Normally what we have is plus or minus 200 kilohertz.
200 kilohertz.
Yeah.
And that translates into
the actual motion on the cavity.
Yeah.
A millimeter or two.
A millimeter or two.
Yeah. Wow. It depends upon the tuning coefficient of your cavity. Wrap cavities are nominally 300 kilohertz per millimeter.
Yeah.
So it really depends with different cavity shapes. It's all dependent upon the cavity shape and the frequency.
Sure.
For our cavities, it's nominally 300 kilohertz per millimeter.
So you can have quite a bit of range. In other words, you can be out by quite a bit.
Well, yes. I mean, but the manufacturing of the cavities is much more tightly controlled. Probably the most tightly tolerance controlled component in the whole module.
It is. Yeah. But to tune it, you basically crush it until it.
No, actually, ours are designed to be tuned in tension. We tune the cavity in tension.
Tune the cavity in tension.
Yeah, so that way you don't have to worry about any kind of banana effect.
That's what I thought.
Tension.
That was a going debate. You couldn't figure out whether you were tuning in tension. Yes. So it's no buckling to worry about or anything.
Exactly.
Yeah, because it's going to wander. Yeah. So that's your primary mounting tabs here?
Yes, they mount to the helium belt.
And that's what keeps everything aligned. Okay, and then so when this goes up to the top, to the motor, it's basically free to float. No other fixed connections to anything.
Like I said, it's a concentric tube setup, so essentially these will bolt through the vacuum vessel, which is your transition from your insulating space to your atmosphere.
That's right.
And essentially they'll bolt to two concentric shafts that are essentially your drive mechanism. I can show you a assembled one outside sitting out there.
I understand that, but I'm just wondering if all that's basically, it's vertical, right? So there's no side loading really, except for when it moves around a little bit because of cooling.
Installation, when we put these on and we get the frequency set on the cavities, we have a locking feature that will lock this in place. We don't want the cavities moving around as it goes through its assembly process. When we put the tuners on, we actually want to preload the cavities so that they're on frequency when they're cold at 2 Kelvin.
I see.
So that's understanding what frequency the cavities are at and making sure we get that set right, because we can't reconnect any of this after it's buried inside the module.
Right.
To get all that set right, then we have a locking mechanism that locks this until we get it all the way out and bolts it up to the motor. Okay. Copper thermal straps that go to our 50K shield.
Right. Okay.
We have a
that's what we thought.
heat intercept. That's basically optimized, and that grabs both the outer shaft and the inner shaft that grabs the bottom. Right. So those are essentially the heat intercepts.
And this is strong enough oh wow. Oh, I see. I guess once you got both of them together, it's pretty rigid.
Yeah, once it's bolted on, it also has the connection coming through the vacuum vessel, so it's also anchored up top of the vacuum vessel as it comes out. But I'll show you a fully assembled one we have out front.
Okay, that would be
right.
Yeah. Okay, so it couples onto the tuner right there.